All right, welcome everybody. Welcome. Thanks for coming out to part two of this platform engineering space. I have Akansha alongside me as a co-host, and we also have Carlos, who's going to give us some deep insights as to what he's been up to with some of his projects in platform engineering. I'm hoping that Kat shows up as well, hopefully, because she is invited, but we'll see. Anyways, so if you all missed the previous space, feel free to go check it out. Akansha, if you've got a moment, feel free to pin that to the top so that folks can go catch that session, which is more of a primer around platform engineering. We were trying to understand why now, what is it, and we were hearing from perspectives. We're hearing from perspectives both from Dell as well as SUSE, or more specifically, Tim Banks from Dell and Rob Serchia from SUSE, or SUSE. I don't know how to pronounce it. I'm going to get flamed later on. Anyways, I will go out and I'll pass it along to Akansha, and then we'll get Carlos to introduce himself shortly. Let's go.
Hi everyone. So I will just set up the stage and then Carlos can take over. So today we are back with another exciting space session. So today we are diving into the practical world of platform engineering. So as Marino mentioned that in our previous space, we have touched on various aspects of platform engineering, from the challenges it poses to the role it reshapes within organizations. But today we are taking a different route. We are shifting our focus from theory to practice as we explore real world use cases that showcase the incredible impact platform engineering has on businesses and industries. So is not just a buzzword or an abstract concept. So whether you are a technology enthusiast, a seasoned platform engineer, or someone looking to demystify the functioning behind software development, this session is for you. So it was around 2022 that organizations looking to.
Uh, Akansha, we seem to have lost you for a few seconds there.
Oh, okay. So, like I was saying that it was around 2022 that this practice started gaining momentum, especially in organizations looking to take forward in their DevOps transformation process. So, according to Gartner, the platform engineering wave will involve 80% of IT companies by 2026, with the promise of optimizing the developer experience, accelerating the product development, and increasing value to end users. And today we have Carlos and okay, we have Kat as well. And they are here to share their experiences and insights into these real world use cases. And we will see that how platform engineering is shaping the future of businesses and empowering developers, enhancing the security, and enabling the seamless deployments. So, yeah, Kat and Carlos, feel free to introduce yourselves and we can move ahead later.
Sorry, who wants?
Yeah.
Yeah,
I
go
can go
ahead,
first.
Carlos. I think Kat might be having some audio issues.
Sure. Can you hear me okay? Or I need a different
Yeah,
mic?
I can hear you.
Okay. So hi everyone. I think we have a few folks in here that are starting to join, but if you're listening, also reach out. My name is Carlos Santana. I'm a senior specialist containers solutions architect. That's long for saying a containers SA. Working with EKS, and for the last year, I've been working in AWS, working with customers as a customer-facing role on this concept of DevOps, platform engineering, using Kubernetes as the API to build internal developer platforms with multiple customers. So happy to be here.
Thanks, Carlos. Yeah, so like Carlos, like what is your take on like platform engineering? Like what's like before we actually deep dive into the real world use cases, like what you have to say about platform engineering?
I think I can say a lot of things, but I was listening to part one, so we will not want to make it a repeat. But I like the conversation about the DevOps aspect and the cultural aspect of the DevOps culture, and at the high level, platform engineering is basically when we talk about platforms. That's again, we don't want to make this space about like defining what is DevOps versus platform. But one of the things is a lot of businesses are trying to build a foundational layer. So if we replace the word platform for foundational layer, then that is something that will help like understand better what they're trying to do to support the execution and operation of applications. And the idea is to provide abstractions around hardware, operating systems, and runtimes. And platforms are very broad, like platforms such as AWS or another cloud. They offer a range of services, including compute, storage, network, databases. I think that's where it starts. So a lot of the aspects that I have worked with is a lot of businesses coming into that I talk to, and the teams that I talk to are coming from the standpoint inside their companies that they're under an organization called platform engineering, and basically that's is associated with cloud, on how that business uses the most efficient way and secure way cloud, and then how do they provide those cloud services to the rest of the organizations to participate and use those services in the most efficient manner, including cost. So that's kind of like the aspect of platform engineering, what I'm seeing from the businesses coming to asking us for help. And what we just relate is what we work with other customers of, like how their other customers are being successful to leverage the cloud in a way that not everyone needs to be a cloud expert, but everyone can be an expert in their domain, if that helpful.
So I know that you have worked quite a lot with building various platforms for a number of different use cases. Maybe you could share with us about some interesting use case that you have seen the organizations might have needed.
Sure. So the one of the things that I've done with many customers, and I think I posted yesterday. We can link it here on two blog posts that came out recently. I'm working on more to make these use cases public, and the idea is to help other organizations to do it. But one of the things that we do with customers is look for that empathy of that DevOps cultural aspect of it. Of since we're working with the IT team, or the IT team that has access to the cloud, like the team that can create an AWS account, for example, or the team that can create a cluster, the team that can create subnets, the developer that usually is the majority of their engineering force workforce is developers, and then this team is kind of an efficient team, like a smaller team, to maximize the efficiencies to use that. So when we talk to customers, we ask them like, who's going to use it, and they get surprised because they believe they know who's going to use it, they know how they're going to use it. And one of the surprise that we get is we just want to talk like, who's the end user, and the idea is to get empathy, to get that mindset of, if you're going to do platform engineering, you're going to do like a product inside your company. You're going to do a product for a consumer inside your company, and that consumer usually is a developer, an application, and later I can talk about a new one that it was very interesting to find out that I don't know how to say IDP with science in the middle, but we did a project with NASA that the end user wasn't a person that writes code. It was a person that does science with data, so it doesn't know anything about software. But we're going back to the majority of use cases is they have a lot of developers that they're efficient on what they do, which is writing Java, writing Node.js, talking to REST APIs, working, understanding like the security aspects inside the app. So they are not experts of like, is it this, my application is going to run on a VM? Is it my application is going to run inside a container? Is my application is going to run inside a Lambda function? but they're very efficient on what they're doing. So we try to tell these platform teams, get someone from the app team or developer team to represent them, so that way we provide something that is satisfy that need and build abstractions for them. So that's the first conversation we do. Is like bring someone from the development team. If you are the platform team or the DevOps team and you want to build a platform, you're building a platform for someone. And the idea is to bring that person in and say, these are the things that I'm aware of, and these are the things that how I want to use this platform. And the idea is to provide that empathy of like for the platform team to have for the development team. And I will say so this is I want to say the story. The interesting part, I was surprised also because I'm in the I did app development and the web development, cloud engineering. I'm a nerd in that area, but I'm not an expert in scientific models of running on HPC clusters to do weather predictions. So what the project that I did with NASA, it was about providing these scientists, which I learned that there's data scientists, and something that I was doing that I felt a little bit bad was I was calling all these folks data scientists. I don't know if people want to raise their hand. Like we talk about data scientists. I've done that. Who have done that? And the person on the other side, like we are not data scientists. We are scientists that work with data. Yes, we have data scientists in our team, but we have scientists that work with data, and we don't know we're not aware of like Git. We're not aware about saving source version control. We work on a Linux terminal. We work with models. We work with algorithms. We run jobs in parallel to get results and reports on those. So they don't have a software development cycle background. So sometimes we have the perception that everyone that is doing an IT project has that background, and they don't. So if you try to build a platform that is for developers, but you give it to a scientist, then that doesn't meet the desired outcome. You didn't know the consumer of your product, and that's I think why it's important to know who's consuming your platform, who's the audience, so you can build the right interface for them, right? To meet them where they are, and not necessarily tell them, well, now you need to know about source version control. Now need to know about software developer practices because a model needs to be versioned and the model needs to have testing, but they're not aware of that part. So, but the IT team and this platform team can help build something that they can use of going to a website, and the blog post has the link to the a free version of the platform. You go to a website, you click a box that says Open Science Studio, and you click on it, and you get a Jupyter notebook, and they're super happy. That's what they work with. They work with notebooks and Python. So I'll leave it at that. Right? If there's any question, go, Marina.
Hey, Carlos, thank you so much for getting into that. I actually have a follow-up question just to kind of add to that momentum that you have there. So, when you're working with clients or customers or folks that are trying to build out an IDP, what is the process of discovery? Like, how do you go about asking them the right questions so you know what they already have and then what their gaps are to continue to build out that IDP?
Yeah, so and actually, I don't know if there's customers here in reInvent. I will have a few talks that I will draw stuff in the whiteboard and go through that discovery process. But in general, what we do is we give a presentation on what we have seen with other customers, and we ask them if they're in the same situation or similar situation. And the primary use case that when we ask them is that we for the developer aspects of it, and some of the projects are like developers that are building containers, and they're deployed on Kubernetes. Notice that I didn't say the developer is building the container and deploying to Kubernetes. I said they're building containers and the app is running Kubernetes. They might not be involved on deploying the Kubernetes. So, but the next level of abstraction that they're looking for in cloud platform is sometimes they have figured out the CI/CD pipeline, like that's been around for a while, like building a container, pushing a container, deploying the app to Kubernetes, building CI/CD pipelines. Where it gets tricky is we ask them like, how does a developer of this app get a resource from the cloud, right? And that's where the platform teams like, well, the platform teams would give them access to the resource, and that resource could be, let's say, a Postgres database or cloud object storage bucket that an app needs to talk to. Like most microservices have a state, have an API, like a backend API, NoSQL or SQL database, and the database needs to be deployed for that developer. And we just ask them like, how long does it take? Like we try to ask them, like, how long does it take for a developer to, like after he configures the database and maybe he configures the database locally in his laptop, like how long does it take for the database to be available in the staging cluster and then available in production? And how they go about it? And they say like, well, it takes about 3 weeks. And some organizations, that's super fast. Like, oh my God, 3 weeks from used to take 6 months. Other people have different perspective, like, oh my God, it's 3 weeks instead of 1 hour, right? So we just try to understand like where is time consumed to get a resource, because in AWS we provide you an API that you call it an API, and in 10 minutes you get a Postgres database. So why is it taking so long? Well, the reason is because we asked them, what is the process for a developer to ask? And would you believe it or not, they don't know. Like that team doesn't know. So that's where we bring the developer and somebody from the app team, ask them like, what did you do to create a platform? Ask for a database, and they just say, opening a ticket. And that's most of the teams just open a ticket, either Jira, ServiceNow, and then we ask them like, well, what is the process? They open a ticket, and then what happens with the ticket? Or some cases they and I will talk about the solutions. Sometimes they say like, well, we give them back Terraform and it takes 3 weeks. Well, why, if you're giving Terraform, why does it take 3 weeks? And we ask them again, the developer, why does it take 3 weeks or 4 weeks to get that Terraform deployed from your laptop? Is because the developer doesn't work with Terraform every day. He works on Java, and Terraform, he's just looking online and looking for examples, and it doesn't work. So that's kind of the discovery. We just ask questions of like, and sometimes they don't know. So that's where you need to bring the other counterpart into the same discussion. Go ahead, Marina.
You know, that's it. You brought up something towards the end of that around tickets, right? Raising tickets to get access to something. And you know, it's fascinating because that concept has lived on forever, for like decades, basically. Back when I was in ops, we're talking, late, I don't know, maybe early 2000s, somewhere around that time frame. Everything was a ticket. You want something, you got to raise a ticket, and it would get actioned upon in a sequential manner based off of priority, and then you also have to pair that with any sort of procurement requirements and lead times behind that. So you think about what you just suggested. Someone requests a database, and they should have almost instantaneous access to it, aside from the subtle building process that happens behind the scenes. And it's taken us so long to get there. But I'm bringing this all up because I sat there providing pillars of storage, compute, networking, and some other bits and pieces so that developers or other teams can be able to carve out what they needed. And we're still doing that today. It's really funny. We haven't really changed from that mindset. We're still doing that today. It's just procurement times have been sped up substantially in a positive way. But here's the funny thing, right? So all that we're doing towards this whole notion of platform engineering almost resembles us trying to just recreate Heroku all over again. And I'm saying that because this is how I'm seeing it. We're trying to cherry pick the right necessary pieces or subcomponents for the platform, and then ultimately hand over an API to developers of various skill sets and capabilities for them to be able to say, hey, I'm going to go out and build what I need. I don't need to care about the underlying infrastructure, but the output should be some app that's already published with policies wrapped around it, accessible to the necessary components, certificates added in. So, there is encryption all the way. It's the full gamut, but that sounds like Heroku. Tell me how what we're doing with platform engineering is any different. Go ahead,
We
Kat.
got your mic is working now, hopefully.
Hey, am I here now? I'm here now. Yes. Okay. I made the mistake of trying to join a Twitter Spaces to speak from my web browser instead of on my phone. So here we are. All right. So I really appreciate some of the points that Carlos and Marino have brought up just about and Marino, the Heroku thing is a lot of fun. The conversation's been going around pretty infectiously lately. So I kind of want to relate platform engineering in some familiar terms for anyone who has benefited from platforms themselves, whether you're building platforms or you're in DevOps or you are a feature developer. You don't have to have that experience to appreciate what a platform engineering team does. And one evidence of that is Twitter or Facebook or any of these social platforms where we log on in order to communicate with other people, whether that's, sharing pictures or laughing and telling jokes and, all the things that we do on social media. We don't have to be highly technical to succeed at having those engagements and producing those, value add experiences or participating in them when we get on a social media platform. And platform engineering ends up being the exact same service delivered to professional teams. So if you are delivering a platform to NASA, or if you are delivering, a platform to a banking institution or something like that, you're aiming for that same life quality improvement, so that the people who are good at what they are doing in their profession don't have to know all the ins and outs of technology. And if you look at something like AWS, you see AWS taking off, not because they invented any, revolutionary new technology at the outset, but because they took, massive hypervisor, as a service and made it consumable and enjoyable and easy to use. And now here we are, 10, 15 years later, and I don't think anybody looks at the AWS API or the AWS web UI and says, oh yeah, this is simple and consumable, right? It is consumable, it is usable, but it expands such a wide gamut of capabilities that we're back to that original Heroku puzzle of how do we make this complex thing easy for a specific group of people to reach their end goal without fatigue, right? So I've been enjoying watching the industry as a whole continue down that same journey and reinvent the same problem and the same solution over and over again.
Carlos, would you like to share your thoughts around that as well?
Yeah. So the question around Heroku is interesting, and going back to the ticket is when you say Heroku, I think you're meaning like self-serve, right? You're paying X amount of work, or you're doing a hobby, and you go into a website, you click a button says I want to build a Node.js app and connect to a NoSQL database, and then click this button to get a DNS name, and then boom, you have something that you can do. the thing about tickets is they're not bad, they're necessary. And the part that is bad is like the reason that it takes so long, right? For certain industries and regulated environments, you need tickets, and for some folks have a version of tickets because they have one end of the ticket of like waiting on the ticket. But I have done I work for another cloud provider, and we needed to have change management and separation of duties. Those are things are there for a reason, and and you can say that back in the days where there were tickets, you can say today like, well, I don't want like tickets, I like to open GitHub issues. So now you track all your work with GitHub issues. But if the issue takes 3 weeks, we're staying in the same place. So that one of the things that we're telling customers is have the ticket, but the ticket is just a database entry somewhere that is change management. So everyone that is participating, like Kat said, of like doing their work and what they're good at, and then just have focusing on productivity, so you can leave at time from work, right? Where you can enjoy your weekends, and then just do what you do are your best constantly and not doing task switching. That ticket is the place that we just put status updates, right? That somebody requested a database. Okay, well, the next minute, like somebody clicks a button and it says like, automatically, or just click a button saying, well, okay, then checks that all the requirements are there, or if this is a database that was requested in the past, or it's the same project, or it's just from creating a second database from staging or pre-prod and prod, then the automation takes in place. So that's where the CI/CD and DevOps folks come in place of anyone that configures that database. The ticket keeps getting updated. On the next stage, maybe somebody configures the security firewalls for that database, that only that application can talk to the database, and then they update the ticket, right? And then the other one adds the monitoring and operations, Grafana or whatever is your cloud provider, or if using AWS, use CloudWatch, like configuring dashboard. So then giving access to the developer, that could be another team. So like I said, like everyone has their role in this deploying this application. So you build a platform that everybody can participate and then just focus on what they're good at. The ticket's still there. It's just a change management control. So you can go back and say like, who was involved in this deployment. So if we need to update it or we need to replicate it, we can see it there, and then we have track of like of those things. And then the last one I forgot to mention that comes up a lot is cost management. Like, how do I know that this app is using this database, that is consuming this network, that is using this storage? How do we measure like how much cost is the amount of that? And then internally, that's how businesses do chargeback on knowing how much cost, and then they can evaluate if enhancements needs to be done. So that's why most of these people are reinventing the wheel, because they need to adjust it to their internal way of doing business. And some businesses are like advanced and they have a lot of engineering power. Some businesses are just getting started, right? And they need like some framework or where to get started. And that's something like we started a project called Canoe, CNOE.io, to build IDPs, kind of like to get started, or like what if the stack looks like. But that's, I don't know, Marina, what's your take on tickets? I tell people like tickets are not bad. It's just change management. They get automated. They're still present. Like they're not going away.
Yeah, it's fascinating. I don't think tickets ever will go away, but they'll show up in different forms, right? So you think of a PR or an issue, and that is in its own form a ticket, because you're making a request to effectively do something, modify something, improve upon something, which is very much a similar approach to just raising a ticket so that something can be created. I think we're evolving towards that state where we can use the collaborative tools that are available to us to effectively raise those tickets, whatever they are, and see those changes come in very quickly. But that's like paired with a bunch of other things as well. So, for example, there was a question that came in from Siddhant about tools like Crossplane and Backstage. I'll be very honest. Like I haven't spent a lot of time on the Backstage side, but I've been looking at what Crossplane is doing, which is I feel like almost very similarly capable to what Pulumi does. And I'm not going to comment further on that. I'll let Kat come in and share thoughts around that. But you need some sort of orchestration platform that's not orchestrating specifically your containers or the workloads themselves, but the underlying components, right? And that has to happen just in time. So it has to happen almost instantaneously. So for Carlos's example, right, someone wants a database. It's not someone on the platform team that is going out there to provision a database for that developer to access. It could be a simple approval a process, or if certain thresholds are met and it doesn't potentially exceed those thresholds, or that request isn't doing something, it's like an approval for an expense report. If we're not exceeding a threshold and we're within that threshold, then maybe it just automatically gets approved and gets created. But if we're asking for something that might be substantial, that could impact other environments or other parts of our environment, that's where maybe that more detailed or defined or definitive approach of let's investigate what this actual request is before we approve it comes in, right? And so there's that model is going to be different for a lot of different organizations. And I just saw Engen show up because I mentioned Pulumi. Oh my gosh. Kat, feel free to share your thoughts. I mean, I know I called your company out. Sorry.
Yeah, Crossplay and Pulumi are both tackling similar problems, and that the orchestration piece might seem like just its own technology puzzle. But one of the things that I really like to see with the adoption of more multi-cloud, broad automation tools is that we look at this ticketing conversation differently depending on the constraints of the tools that we use. So in the case of asking for a database to be provisioned and that taking 3 weeks or 6 months or maybe just an hour, the blockers or the controls that allow that to be done responsibly are instantiated differently depending on the engagement model that you have with your platform. So if you're just using AWS directly, or your in-house Kubernetes platform or whatever directly, and you don't have automated like GitOps in place or things like that, then you're relying on humans in the loop to control the authority of who has access to what systems. And relying on those people means you have decreased visibility into what the changes that are occurring when a ticket is placed for a new feature or a change request or what have you. And the more opaque things become, the more rigid and fear-based an organization will become when it is faced with any change request. But when you implement more GitOps style practices, two big things that I love happen. One, you have more transparency to why the process exists the way it is. If I am a platform user and I want to understand how come when I create a database, I am constrained to 16 gigabytes of storage and my databases keep filling up, I can go directly to the code and answer that question for myself if I'm proficient enough in it, right? Or if I don't know those things yet, when I do engage with someone who is on that platform team, the DevOps team, what have you, they can actually show me in code. We can communicate based on evidence and information, so that if we actually need to change a policy in the platform, instead of just change a feature or create a new feature, we can have those conversations cross-organizational to establish why the business culture is the way it is, how it's affected, and adapt business procedure to improve, everybody's working life, reduce the workload on humans in the loop, and, increase velocity of changes in a way that is transparent and auditable and increases trust across organizations instead of the opposite, where it's like, well, I submitted a Jira ticket or I sent an email or whatever, and some magic is supposed to happen on the other side of that opaque wall, but I don't know what it is. And then that, leads to tension and fear and finger pointing and all of those things. So even if the process doesn't accelerate as a result of adopting automation tools, um, the improvement in visibility and trust across an organization all by itself is worth the investment, in my opinion. And that's one thing that I really like to watch and see happen in real life.
By the way, when I put up my hand, it's actually more for me so I can remind myself that I actually have something to say, because I tend to forget at times, and it really is to kind of answer something that Kat said around a repeatable process. And what's very fascinating about this is that whole repeatable process, being able to, maybe quote unquote say lift and shift, is is something that I think a lot of organizations have been driving to obtain. Right? They try to get to this state where they can truly lift and shift, and tools like Kubernetes have helped enable that or further that journey along. But when multi-cloud enters the chat, nothing is ever consistent. And that consistency is never going to be available to you because of the way the different cloud providers write their APIs. And so, to Kat's point, right, this is why tools like Pulumi's, I don't know what Pulumi's product is called. I'm sorry, Kat. You can come in and share some of that. But, the platform that Pulumi offers, similarly to, what Crossplane offers, is that experience that's tying all the necessary foundational pieces together, but then also offering up that API where folks can come in and say, I don't like that cookie cutter model or that cookie cutter fit. I'm just going to tweak things according to what I need it to do and then replicate that model. But that also creates the repeatable process where you say, hey, I am done using, Microsoft Cloud. Sorry, I had to say it, or Azure Cloud. And I've decided I'm going to move everything to AWS, or maybe I want to use a bit of both, but I want to maintain those similar practices across the two without having to like sit there and re-engineer every single time I move things around. That's the biggest challenge. I'll be honest, back when I was at VMware, this was the this was an interesting problem that everyone was trying to solve. VMware was trying to solve this. Red Hat was trying to solve this, and they did in their own ways. And VMware offered the SDDC and basically suggested that you kind of need vSphere to make this possible, but you also kind of need actual hardware to make this possible. And out of that whole notion of SDDC or software defined data center, which in itself was a platform, was this concept born multi-cloud that VMC offered or VMware offered. It's still a platform. It's still solving that same problem that Kat was just talking about, but now you have these heavy proprietary hooks, right? Now you're locked in, and that's another conversation we can have as well. But it comes down to a business trade-off. Do you compromise your customizability and flexibility for everything that works, everything you want it to work, it works the way you expect it to, or do you lean more towards the build it yourself, complete customization, but now you're left being responsible for the maintenance of it? So it's a very interesting approach. And so Carlos looks at it as I am there to look at a customer and not sell them on everything that's AWS, but really get down to the problem of what they're trying to solve, and then assess whether or not they've got the right bits and pieces. And we could start talking about roles and functions and whatnot, but ideally we look at everything today. It's a platform. AWS is a platform. Kubernetes is a platform, but you also have to customize it. And then you also have to pair it with other tools to make it truly resemble something that a developer might want to consume. All right, I'll stop. I'll pass it to Kansha if you want to extend that conversation or move on to something else.
Yeah, so like I had one question. So, like we know that vendor lock-in can be a concern when implementing platform engineering for multi-cloud environments. So, like I wanted to ask to Carlos and Kat also, like what are the most common forms of lock-in that organizations face, and how do you suggest addressing while ensuring platform standardization?
Yeah, I can talk a little bit about that. I mean, this. Well, we've been talking for a long time. I want to tell some stories about the practical implementation of cross-plane and just to help others. But the vendor locked. Some customers, what they're doing is, and this conversation that we have with them is, like Marino said, these organizations have built. So we had the teams that didn't manually, right? We talk about tickets, and then the platform team used a tool like Pulumi or Terraform or CDK to deploy this. And the next type of users were like, we're not going to make them wait. We're going to do something better. We're going to give them Terraform, and then they can run Terraform the laptops. These developers, they will love it. That's not true. I'm being sarcastic. That doesn't work either because the developer doesn't work with Terraform every day. If they work a lot, they would do it. And sometimes we say like they will give them an SDK that they can use programming language like Python, Go, Java, and that's where like Pulumi comes into place. CDK is a tool that we have that you program in Python and then generates you the S3 bucket. And the last one is that what you're asking about is they create their own API because they don't want to do vendor locked. So they create a REST API and a web UI also, like a web UI, a CLI, a REST API. And this platform team is spending a lot of engineering power to say, we want to provide an API that, like, if you go to a website or a REST API CLI, there'll be a REST API that sends us JSON on what, like, the bucket that they want to create for the application to put files. And then they start looking like, well, we need to, in that API, we have to run it somewhere. And then like, okay, we'll run it in a container or EC2 or VM. Oh, we need authentication. Oh, okay, so we add authentication to this pipeline. Oh, we need authorization because like some certain things need different authorization. Okay, that's fine. Oh, we need policies also. Like we need policy control about like validation of like the JSON is correct for this API. The types are correct. We don't want to. We have to look at the APIs that we're calling in the back for AWS or whatever, or on-premise to create the database or another cloud. So as you can see where I'm going with, they created their own abstraction, spend all this time building an abstraction to give back a REST API that then like is robust and can do all these things. So they can do it for this cloud, they can do it on-premise. And some organizations practically we're going back to them and say like, well, what about if you use some open source framework or open source tool to build a REST API that has kind of like a runtime that has these things by default? And by the way, you are using Kubernetes. Why not use Kubernetes as a control plane to offer an API, a REST API? As if you know Kubernetes, at the end of the day, it's just a REST API. You may use kubectl a lot. Start using -v6. I'm a nerd. I'm still a nerd. kubectl. -v6. You will see REST API in there. So a lot of organization practically, and this like you mentioned, cross-plane, people using ACK, they are taking Kubernetes as the API, and then what they do is they build controllers or reuse controllers like in cross-plane. And then they use the Kubernetes as the programming model. So they would use the Kubernetes RBAC to put people in namespaces or APIs in namespaces, so they cannot create. They can create a database, but not an S3 bucket, or they can have validation to make sure that the database is not bigger than 100 gigs. They can have authentication, so they're authenticated against the REST API, and they can have inventory state where they can, like, do kubectl get all these databases on this namespace represents the team, and they can get all that information. And then the tagging, if the app may be running on Kubernetes, some apps are just deploying like Lambdas or like just deploying S3 buckets, they're not even running in Kubernetes. But that's one way of we've seen in practical terms Kubernetes being used as a like a CI/CD runner, if you can take it, or a Jenkins runner that offers a REST API to another front end. That could be Backstage, or that could be GitHub, so that could be a CLI to implement that abstraction that then they use Kubernetes inside to talk to on-premise, to talk to another cloud, or run a CI/CD pipeline, or do Argo workflows or Tekton, or just a controller with GitHub. So that's one way that actually people are tackling the like vendor locked in, or maybe not vendor locked, but using a standard API or a standard framework that then when you hire folks, then you're not hiring folks to work on this custom monolith IT CI/CD REST API, that you're hiring to work on Kubernetes as you leverage all these engineering that already like trying to learn Kubernetes and practice Kubernetes. They can also help in the platform team. I'll start there if Kat wants to add something.
Yeah, Carlos, there's good call outs there. And can you hear me?
Yep, I can hear you.
Okay, good. Yeah, Carlos, you called out Kubernetes as an opportunity for breaking out from some of the vendor lock-in risk. And I definitely turn to that solution myself frequently. The lock-in conversation, the way I see it, is a few different layers, though. So lock-in as a whole represents a fear that suddenly we're going to be held hostage by our technology choices, or otherwise held back based on the limitations of the choices that we invest in compared to whatever the next greatest thing is, right? So maybe we build an OpenStack platform, we make it completely functional, and then we find out down the road that OpenStack is suboptimal compared to maybe how Kubernetes and a fully integrated AWS environment, which might serve our needs better in the future. But this idea of lock-in, if we unwrap what each choice results in, ends up looking like vendor lock-in, talent lock-in, corporate lock-in, because all of these choices result in a matrix of decisions, including financial investment or contract signing, including who we hire for our technology teams, and what talent or what skills we empower them with. So if they're getting more certification in Kubernetes or going to conferences specific to whatever platform we're investing in. And then also business policies, because once you create a solution based on technology, you integrate that deeply into your business with policies that dictate the business behavior, if the business wants a change, or that dictate and box in what evolution in the business is possible within the constraints of the technology that it's invested in. So I worked significantly on a DoD, Department of Defense project, which was aiming to create the most open source and vendor lock-in free platform in a box for consumption and utilization across DoD and other public sector organizations. And every step that I observed, which carried them further from a specific vendor lock-in, was equally, it's almost conservation of energy here. You know, every action has an equal and opposite reaction. you're investing in something if you're making steps forward. So even if you're investing in portability based on Kubernetes away from Azure, GCP, and AWS lock-in, you're still investing in lock-in commitment, if you will, to the technologies that you're deciding on. So the main metric that I want to see a conversation appreciate when talking about lock-in is the sustainability of the technology decisions made. So that includes not just the month-to-month cloud costs or IT, financial cost month to month, but also the sustainability of being able to acquire the talent that knows how to operate the technology and understand whether or not you're locking yourself into a tiny talent pool that requires very high salaries to secure, competitive benefits and all that stuff, which is absolutely a great investment depending on the the decisions you've made as a company and whether or not the higher cost is offset by reduced headcount need or reduced complexity and higher velocity and things like that. But as a whole, lock-in in general is a conversation that needs to include technologists, the professionals that are utilizing the platform, and the overall long-term business strategy, as it's looking 3 and 5 years in the future to understand employment market changes and all of these other things that affect whether or not investing heavily in, say, AWS might be more long-term sustainable than necessarily developing your own internal Kubernetes platform from scratch, which might also be viable for some businesses, but counterproductive for others. So it's not always a philosophically pure or black and white conversation. And I think that's one of the reasons I like it, because it does vary so much from situation to situation.
Thanks, Cal. Marino, would you like to add some thoughts, or I go ahead with another question?
I'll just kind of add the bit of around proprietary technologies and what ends up happening there. I mean, there's a lot that has to go into a business decision, right? And it really comes down to how quickly something needs to get out to turn into revenue, and that ends up translating to technology. So if you are to sit there and piece together the open source cloud native landscape to basically build out that developer platform, it would probably take you a lot longer to figure it all out, to stitch together the interoperability between all of these components and get up and running. Or you have the option of maybe sitting there and trialing out a number of different solutions that are available in the market from a variety of companies that have actually created commercial offerings. But you still have to spend the time and cycles to evaluate. But the beautiful thing is a lot of some of the more established vendors out there have published use cases that you can pick and choose from and be able to customize to your own needs or to your own organizational needs. And so now you start leading towards the proprietary side where you have highly curated solutions that maybe meet 95% of your design requirements for whatever you're trying to build. That 5% is maybe some additional input and parameters that you throw in to make it yours. But the reality is that 95% keeps you stuck. There's some gravity towards using a particular vendor. And now when you decide you have to move, it's a process of re-engineering all over again for that new place that you decide you want to move to. So it is always going to be a business decision. You'll find organizations that tend to pendulum in both directions. Sometimes they start off building their own thing and they're like, oh no, this is not going to work out for us. Let's just go over to that vendor that has already built this out, has a support model in place, and we can work with them. And then they decide down the line that it becomes such an operational expense that maybe it was better to to continue building out, right? So you'll see this time and time again, and a lot of organizations will go through this cycle as they're growing. But that's all I'll say there. Akansha, I'll pass it back to you for closing thoughts.
Um,
Oh yeah, go ahead.
One before we end, one of the things that we have learned working uh, with end users, trying to practice the platform, and some users are already doing platform engineering and they don't know it, right? They're offering like services internally. It's just they see the hype of platform engineering being a new name, but they're already are helping the organization with their cloud resources. In this case, we're talking about platform. My case, cloud. But one of the things that we do, like you said, of like making decisions, paralysis analysis of like long studies of like which vendor do we pick, which workload do we move. We tell them like take it down to like practical terms of picking. We work with them. We engage with some strategic customers. The bigger ones. We have time, and we have me and myself and others. We dedicate a few weeks. We do a program with them, and what we do, we tell them is like, never say that you are building a new platform. You're not building a new platform. What we tell them is you are extending the platform that you have with new capabilities or enhancing it to make some workload better. We ask them to pick a workload that is currently in production, so you know that it's like developed and it has a path and it's in production. It then have both teams, platform and dev team, align of what that'll be that workload and making one enhancement. And if you will see the blog post that I posted about 6, for them was just an S3 bucket. They had a Kubernetes app, microservice, small microservice that needed an S3 bucket, and they move it from opening a manual ticket and waiting for it because it was lower priority in terms of that, creating buckets, to move it into automation. So they just automated the bucket creation by just having a YAML file, extra YAML file in there, and then that benefited the developers of waiting. And interesting story on this one was that they don't use their portal website. They don't use directly. They don't put the files in Git. They use the chat. That's how they get apps deployed, and they request their app that includes the buckets using a Slack message. That's it. Like, simple. So we tell them to start with a single workload, pick a workload that has benefits to a stakeholder that is above both organizations. That stakeholder saying like, yes, there's a benefit here, business value for me, for you to work a couple of weeks to extend or enhance the platform that we have with a new capability to improve the developer experience. So now the apps are getting faster, they're doing faster POCs, they're not waiting for that ticket. The platform team is not worrying about like addressing the ticket manually. So it's just a little bit of automation. They provided kind of like an abstraction in there to get buckets for the application, and developers like they keep requesting the app through Slack. And I thought it was very innovative in terms of like people finding their way of what works for them. So yeah, just wanted to tell that story around one of the practical use cases.
Yeah, what you just described sounds a lot like what the Kube Shop is doing with Slack. And even there's another organization out there, Rootly, that does something similar, incident management through Slack as well. And that's cool because you're now not creating another thing to learn for people. Basically, they can use what they already know and leverage the tools that they already have to just create those repeatable processes in something, in a space that they're very familiar in, which is you know what, I'll be honest. I actually want to use more and more Slack and automate some of the things that I do. Like if I can create an EKS cluster just by saying, hey, Slack, create me an EKS cluster, And although that's not something I would do in production, right? We're not here creating EKS clusters in production, but the idea is accessing that level of simplicity or accessing the resources we want to with what's like at our fingertips. So anyways, I just want to throw a quick shout out to Zara Sedant and as well as Adarsh, who is a CEO as well as in the platform engineering space. So thanks for coming along to this Twitter space. I think we're about to wrap up. Anyone else wants to share any final words? I've got to get to my next meeting in the next couple. I'm actually overdue, but that's okay. I'm sure they'll understand.
Hey, I like the whole Slack entry point into the natural language operations conversation with Gen AI and all of that coming up. Just like, hey, Alexa, create a Kubernetes cluster where it creates a pull request and then you approve it somehow and all that stuff. It's going to be super, super fun.
I didn't imply anything here, but I think the future is looking conversational, right?
Absolutely. Twitter Spaces ops team.
Yeah, so there were some really amazing insights today. I certainly understood quite a lot more about platforms and I learned a lot. So I want to thank Carlos and Kat for joining and sharing ton of fascinating knowledge around IDPs. And I hopefully we can do some more spaces around platform engineering because it's still developing quite rapidly. And thanks, Marino, for co-hosting and everybody who has tuned in today. It was really amazing.
Thank you for the invite.
Thank you, everyone.
Awesome. Yeah. Thanks everyone for coming. If you haven't already, follow Akansha, Carlos, and Kat on Twitter. They always drop some fantastic tidbits here on Twitter for us to learn from. As well, we will be running another Twitter space next week on Halloween, October 31st at 10:30 Eastern. And we're going to focus more on service mesh and get some of the experts, some of the creators of Istio to come in and share some insights around why they built what they built versus, the introductory, what is ambient mesh. We want to get to the behaviors and the mindsets of why we do certain things and why we build certain technologies and what they're aiming to do for us, how they're aiming to solve problems. So stay tuned for that. We'll catch up next week. Take care, everyone, and enjoy the rest of your week. Take care.